So we are doing like, so summation fx square divided by summation f minus summation fx divided by summation f. So that we have to apply. So first we have to calculate m square values and then summation. Not this summation is not required because we have to calculate fm square summation. So next stage we have to find out the fm square values. So fm square means we have to multiply this with f. So this is your fm square. So these values become your fm square values. Now you have to add all these values. So once coming this, so once coming this fm square, you have to make the sum of all these values. So let's add now. So this will be the value of fm square and then summation f. So you have to make this summation f. So that is 39. And then you have to like minus summation fm divided by summation f. So fm means, so next stage you have to multiply f into m. So that is like, this is your f and this is your m. So f into m you have to multiply. So these values get multiplied and then the summation of this fm. Fine. So the formula becomes standard deviation is equal to summation of fx square. So this is the value of summation of fx square divided by summation of f, that is this value, minus of summation fx is this one and divided by again this 39. So 718, like this possible summation of, put a bracket here. There's certain error in this. To resolve this error, 1 second. Summation f. So इसका whole square भी होगा, like correct this formula. This is having a whole square also. So this is the formula, summation of fx square divided by summation f minus summation of fx divided by summation f whole square. So that means in this formula you have to minus this raised to the power 2. So 64.03, that will be your standard deviation.
Excuse me, sir.
Hello?
Sir, your screen is not visible in my side. Your screen.
Screen is not visible. It's
Yes,
visible
sir.
to me. It should be visible. Others can see this or not? Because I have, I
Visible,
can.
sir.
Yes, sir.
Visible,
It is
sir.
visible. It is visible. Visible.
Oh, okay, okay. Wait a minute, I'll recheck it again. Why this error comes? ठीक है. Fine. So this answer becomes like, for standard deviation, the answer is like 64.03. So this is the way in which we can solve in a one-step process. Clear? Now, if again we have to reduce the calculation, so we can use the assumed mean method in this. So assumed mean method says we have to make one assumption on this. So assumption can be your 7.5 plus 32.5 divided by 2. So 7.5 plus 32.5, that becomes 40. 40 by 2 is 20. So you have to check the nearest value to 20 in the data. So we can calculate dm. So dm value becomes, let's suppose 17.5 as the, so m minus 17.5. So if you calculate dm value, so dm is equal to m, so which will be equal to m minus 17.5. So that will be the value of your dm. So these are your dm values. Now wherever there is x, it is replaced with dm now. Clear? So it becomes like summation of f dm square. So you want the values like dm square. Or if you want to further reduce, because 5 is the common in this also, so you can take m dm dash also, as in the case of step deviation method. So dm dash is equal to dm divided by I. So where I is this 5, so it can be like this, which is equal to dm divided by 5. So this becomes your minus 2, and these all become values like dm dash. Now you have to calculate dm dash square, the same process as we have did yes before. So dm dash is square is like the square of these values. So raised to the power 2, so that becomes your dm dash square. Now you have to calculate f dm dash square. So f dm dash square is, this is your dm dash square value, you have to multiply with f. So f is this multiply by dm dash square, so that becomes your f dm dash square values. Fine. So it is easy to calculate FDM dash square as compared to FM square in case we are working on the manual sheet. We are working on the Excel, that's why it is like seems to be easy, but otherwise on manual calculations, this seems the difference between this calculations and FDM's dash square calculations. Then it comes like FDM dash square divided by summation F is the same value. Then you have to calculate summation FDM dash. So for that you have to calculate FDM dash first. So FDM dash is F multiplied by DM dash. So DM dash is this value. So this becomes your FDM dash. So these are your FDM dash values. Now you have to make the summation of this summation FDM dash. So summation of FDM dash is 67. Summation of FDM dash square is 215. So if we are making this formula in like this, so now the formula becomes, so it will be like this only. The only difference comes is like this x becomes now dm dash, and this x also becomes dm dash. Now you have to check one case in this, as we have assumed mean. So we have, if you remembered in central tendency, you have added back that a in the answer. Whatever you have subtracted it for ease of calculation, like 17.5 we have subtracted. In the central tendency, we have added back in the answer 17.5 to get the same correct answer. But in case of like standard deviation, there is no need to add this 17.5. But the assumed mean you need not to add back, because that is the two terms. In one it is added, in one it is subtracted, so it get cancelled out to each other. So that's why there is no need to add back. But if we have used the step deviation method to divide by I, the answer has to be multiplied with. Once again, one more thing is we have forgotten, this is the standard deviation, so we have to make the square root of the data. So the formula becomes under root of this. This 64 becomes the variance, but you want to calculate the standard deviation, so standard deviation becomes this raised to the power 0.5 under root of the answer. So 8 becomes the standard deviation of this. So in the same way, if we calculate this, so you have to get, we have divided with the I, so then we have to multiply the complete answer with I. So it has to be multiplied with I. So it has to be multiplied with i's to get the correct answer, because we have divided by on our purpose. But plus a we need not to do in this, but multiply I we have to, in case we are doing with this step deviation method. So now this FDM dash value becomes FDM dash square. So this is your FDM dash square value. So which will be equal to 215, make the brackets. So is equal to this 215 divided by summation of f minus of summation FDM dash divided by again summation f. And for this we have a whole square. We have the whole square and then the whole multiply by, and this data multiply by 5. It should come the same. Summation FDM dash square divided by summation f. You go in step by step one, like summation of FDM dash, so is equal to summation of FDM dash square divided by summation of f is the first term, then summation of FDM dash divided by summation f is the second term, and you have to square this. So now this minus this, so which will be equal to 5.5 minus 2.95. There may be some error in the calculation of this and this. Okay, I'll check it and I'll try to resolve in the next class. The problem is like the both the answer should come same, as it comes out to be from the direct method. It is like 8 standard deviation. From this, that 8 is not coming. So that's why maybe there is some error in maybe the previous one or in this one. So I'll check the same and then I'll let you know that how we can. But the objective is this step is a like one step process in which we can calculate the standard deviation at once. Here we need not to calculate the standard deviation in 2 steps. So that is the, but it is only applicable if it is calculated about mean. Fine. So this is your measures of central density and measures of dispersion. Central density, I'm recalling it. In the central density, we can measure it through mean, median, and mode. And in the dispersion, we can make it by a range, then mean deviation, standard deviation, and variance. So variance is none other than the square of your standard deviation. So, and mean deviation, we are making the positive, negative variation with the use of mod. Then it becomes the mean deviation. Otherwise, it is a standard deviation. So that is the descriptor of the data. We want to explain the data in complete. So we have to give the both the figures in totality. Only central density figure will not give the complete information. So we have to give the complete data descriptives, including the central density and dispersion, to give the complete information on the data available to us. So that is your data descriptives. Now the next topic in your life is your correlation and the regression. Hello.
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 Hello. Yes, sir.
Yes, sir.
Yeah. The screen is visible.
Yes, sir.
Yes, sir.
So the next topic is your like correlation and regression. So I'm making it the fresh recording of the same. I'm again stopping this and I'm making the fresh recording now.